Hello and welcome back to our Rusteroids tutorial. Today we will be adding movement to move our player around the screen using the Entity Component System, or ECS, that we added in the previous tutorial. First, let's check that the code does what we expect by entering cargo run. We should see the spaceship and be able to rotate using the A and D keys. If you don't see this, you can do git checkout tutorial 5 to grab the code at that tag. One of the big problems in moving characters in the top-down display is to make it move in a uniform circle. You may have played games where moving diagonally moves you faster because it simply treats the X and Y coordinates independently. One thing we need to accept before moving forward is that instead of using the common 360-degree rotation, we can represent this amount as 2 times pi radians. I won't go into radians here, but essentially this makes every angle in the circle a fraction of 2 times pi. One of the reasons is that radians are easier to work with when it comes to rotational mathematics, specifically these sine and cos functions. Here we can see the two curves produced by sine and cos. One interesting use of this is called the unity circle, where any given angle is mapped to the x-axis using the sine function and the y-axis using the cos function. At 0 radians, for example, we see that sine is 0 and cos is 1, where we'd expect to end up if we applied a single tick while facing forwards, or up on the top-down view. If we were at 90 degrees, or pi over 2 radians, we see that y, the cos of the angle, is now 0, and the sine of the angle is now 1, which we'd expect if we were facing 90 degrees, or to the right on our top-down view. This means that we can take any angle of rotation, represented here by the theta symbol, and get the equidistant translation by applying sine theta and cos theta. We will see this in action in a few moments. Returning to our code, we'll now check that we have the two constants, game width and game height, in our main.rs file. These will be used for boundary checking later on. Then we move over to our game.rs file and set a constant speed for our player, making sure to make it of type f64 and a value 4.5. Then, using the same function we did last time, isKeyPressed, we will check if the W key is pressed so that we can move forward on command. Then we will get the value of rotation in radians, which fortunately we can do directly from the value using the 2radians function on the pos.rot variable. And then we will be able to update the position.x simply by multiplying the speed of the player by the rotation, remembering to call the sine function on it first. Then we will update the y position by doing the same thing with radians.cos instead. Calling cargo run to test our code, we'll notice the ship moves in a very strange way. This is because the y-axis is inverted on a screen, so our application of the cos function is incorrect. I deliberately left it like this so that if you encounter this problem, it might help you find the solution faster. I've made this particular mistake more times than I care to mention. So let's update our function to subtract the cos value rather than add it. And if we cargo run again, we now see that the spaceship moves as we'd expect, moving forward and around based on its angle of rotation. One final problem is that when we disappear off the screen, we disappear forever. We need to add some boundary checking in to prevent this from happening. So we'll scroll to the end of the update function and add in our checks there. If the position.x is greater than createWidth, using the into function to do the conversion for us, then we will subtract the screen width. And if it is less than 0, then we will add the screen width. We can simply copy what we had for the x-axis boundary checks and update them to reflect the same thing for the y-axis. We'll need to remember to update all references to pos.x to be pos.y and for game width to be game height. And running cargo run again, we can see that the screen wrapping is working as we'd expect. So there we have it. We've updated our code to include movement and we've prevented the player character from dropping into the void outside of the screen bounds by wrapping it around the opposite edge. Join us next time when we will add momentum to the player to make it feel like we were in a frictionless environment, as we'd expect to see in space. If you enjoyed this video, please don't forget to click the subscribe button, never miss out on future videos, and if you have any questions, please leave them in the comments section below. For now though, have a great day and see you next time. Bye for now.